You see that cat? That's lunes, meaning Monday, and in reference to the moon, la luna. Lunes. Let's see if we can get Lunes to help us with this video, equations of circles. Here we are with equations of circles. Now I've written here a standard form of the equation of a circle, and this circle has its center at the origin. So if I were to write x squared plus y squared equals, let's say 25, we know that r squared is 25 and the radius is 5. You could sketch a graph of that circle, and you would know that the center is at 0, 0, and the radius is 5 all the way around, and you could just do a little sketch of that circle. X squared plus y squared equals 25. Now here's the standard form of an equation of a circle that has moved its center some units left or right and some units up or down. You remember that HK when we were talking about all kinds of functions. Well, the equations of circles in standard form also have a shift of the center left or right and up and down. So let's just look at this. The center is HK, and of course the radius is r, so whatever this number squared is, take the square root, you could get the radius. So let me see if we can identify the center and the radius of this circle. X minus 3 squared plus, how about y plus 2 squared equals 20. Now, if I gave you this equation of a circle, could you find the radius and the center? Well, I'm going to look at this and I'm going to say x minus h. This is x minus 3. So there's the h. The negative complies with the formula. So the x coordinate of the center of this circle is a positive 3. I like to say to myself, change the sign to get that x coordinate of the center. And the y coordinate of the center is y minus a negative 2, which would be plus 2. So I'm just going to change that sign, and I'm going to say the center of my circle is at 3, negative 2. Now this is x minus h squared plus y minus k squared equals r squared. So to get the radius, be careful, it's not 20. The radius is the square root of 20 because r squared is 20. So the square root of 20, you could simplify that radical, 4 times 5. And I know from experience that the radius is 2 times the square root of 5. You can work it out if you have a little trouble. There you go. So here's a good problem. If we're given the center of a circle and its radius, we can write the equation in standard form of that circle. And that is using the x minus h squared plus y minus k squared equals r squared. Now, I'm just going to take that center and I'm going to do a little trick. I'm going to change the sign of that 2 because it would be x minus a negative 2. because that's h and k. So I'm just going to say this is x plus 2. X minus a negative 2 is x plus 2 squared plus y minus 4 squared equals 5 squared. 5 squared, 5 times 5, 25. That is the standard form of an equation with a center at negative 2, 4 and a radius 5. How about this one? Find the center and the radius of the circle that's written in standard form. Well, the x-coordinate of the center is really 0 because there is no x minus h squared, it's just x squared. So the x-coordinate of the center is 0. I'm going to do my little trick and change the sign to get the y-coordinate of the center, and that's a negative 4. There's my center, and my radius is, that's r squared. R squared. R squared equals 81. R is 9. Done. Here's an equation of a circle in standard form, and we can graph this circle. We can find the center and the radius just by pulling the center from the h and k and the radius as the square root of this number on the other side of the equation. So let's see. The center is negative 2 because I changed the sign, positive 1, and the radius is the square root of 9, which is 3. Can we graph this circle? We sure can, and we can graph it pretty easily. I'm going to come on over here. I'm just going to sketch the graph. Let's see if we can do our coordinate axis. Let's plot the center, which is negative 2, 1. There's my center. And now I can get 4 easy points on the circle by using the radius. Because if I went in 3 units every vertical and horizontal direction, I could get 4 points on the circle and then just fill in with a sketch. So that's what I'm going to do. I'm going to go 1, 2, 3, 1, 2, 3, another radius, 1, 2, 3, 1, 2, 3. I have gone 3 units in every direction, and now I can just kind of sketch what that circle looks like. Not always easy to sketch a circle, but that's not too bad there. Just getting an idea what that circle looks like and where its center, what is its radius. Now we graphed this circle, and I just want to look at the graph for a second because you don't need the graph to do this next part. However, it might be helpful to look at it before we try. Now, I'm going to ask you, we have already graphed the circles. I'm going to see, can you find the x and y intercepts of this circle? Well, I can see that the y-intercept doesn't fall right anywhere on a whole number, and neither does the x-intercept in this situation. It may or may not, but I'm going to assume that the x and y-intercepts aren't actually crossing at whole numbers. And we're going to do this algebraically. So what I'm going to do is we're going to let the graph go, and we're just going to see if we can find the x and y intercepts by looking at the equation. We get to use some cool algebra concepts when finding the intercepts of circles. Here's some of our expert at working algebra fun. Now, we want to find let's first find the x-intercepts of this circle, if there are any. We want to see if there are any x-intercepts, if the circle intersects the x-axis, and where does it intersect the x-axis. So we remember that the value of y at the x-intercept is 0. So I'm going to plug in 0 for y to get the x-intercept, and I'm going to have to manipulate some things. So we're going to say x plus 2 squared plus 0 minus 1, a negative 1 squared equals 9. So we want to solve for x. We want to find where does this circle cross the x-axis. So we need to be a little bit careful with that. We know that this is x plus 2 squared plus 1 equals 9. We're going to move that 1 over there, and we're going to say x plus 2 squared equals 8. What we did was move that 1. Now we've got this entire term squared, and we want to get rid of that exponent, so we know the opposite of squaring that entire term is to take the square root. So we're going to take the square root, both sides, and when we do that, this squared term disappears. We've got x plus 2 equals. Now when you take the square root of a number, you have to put the plus or minus. This is plus or minus the square root of 8. Now we can finish it off, and we can say minus 2 from both sides. So x is positive square root of 8 minus 2 and the negative square root of 8 minus 2. Now there are two x-intercepts. And actually, look at what we did here. On the circle, when we were looking at the graph, you see that it crosses the x-axis in 2 places. Here's a mini lesson on looking at radicals. I just want to kind of think about some things. The square root of 1 is 1, right? The square root of 4 is 2. So the square root of 2 and the square root of 3 are somewhere in between 1 and 2. So actually, the square root of 2 is approximately 1.4, and the square root of 3 is approximately 1.7. So if you had the square root of 8 minus 2, that would be 2 square root of 2 minus 2, which is really 2 times 1.4 minus 2, and that's approximately 2.8 minus 2, 0.8. And if you had the negative square root of 8 minus 2, that would be negative 2 square root of 2 minus 2, which is a negative 2.8 minus 2, which is really a negative 4.8. So these, in the previous problem, are the x-intercepts, 0.8 and negative 4.8. So the x-intercepts are 0.8 and negative 4.8. Just take a look at this. We had our answer to be plus or minus the square root of 8 minus 2. Well, that is 0.8 and negative 4.8. Well, look at here. Does that look like it crosses the x-axis at about 0.8? Sure does. And what about negative 4.8? That is another x-intercept. Now you could plug in 0 for x to get the y-intercepts and solve algebraically the same way. But look at this. What happens in this circle if it doesn't across the x or y axis. You think you'll be able to solve for that algebraically? Check it out when you do the U-try. See what happens. Let's look at the y-intercepts of the circle. Now, if there are any, that means at the y-intercept, the value of x is y-intercept 0. So I can plug in a 0 for x, solve for y, and we'll get the y-intercepts 0, right? So 0 plus 2, 2 squared plus y minus 1 squared equals 9. And we have y minus 1 squared equals 5. Now we've isolated that squared term, so now we can take the square root of both sides, and that just gives us y minus 1 equals plus or minus the square root of 5. That's what's going to get us our 2 intercepts, right? So now all we have to do is add 1. Make sure you add it off to the side because it will not join the 5 under the radical. And we've got the y-intercepts when x is 0 is plus or minus the square root of 5 plus 1. Well, really, that's 2 different answers. That's the positive square root of 5 plus 1 and the negative square root of 5 plus 1. Thanks for helping, Lunas. And thanks for watching.